morning, students. Chapter 8, Gravitation. Yes, we will see some questions today. Assuming the Earth to be a sphere of uniform mass density, how much would a body weigh halfway down to the center of Earth if its weight is 250 Newton on surface? See, in last lecture we have discussed about the same type of question, but difference is in last lecture it was above the surface of Earth, now it is below the surface of Earth. See, last line, if weight 250 Newton on surface, so first of all I will start from here, okay, here on surface of Earth, it is sphere, its center on surface of Earth, its the weight W1 is equal to, it is nothing but it is mg, because what is gravitational acceleration on surface? It is g. Yes, gravitational acceleration on surface is ge. So how to write? W1 is equal to, it is mge is equal to, it is 250 Newton. That is here. Okay. Now, see, assuming the Earth to be a sphere of uniform mass density, how much would a body weigh halfway down the center of Earth? Okay, it is Earth, it is center. From surface halfway down means at this point. Halfway down means this depth d is equal to, it is re by 2. This depth d is equal to re by 2. At this point, what is its weight? Okay, so see, at depth d, weight, what is weight? So that weight W2 is equal to, it is mg d, if you remember. Okay, from theory we have discussed three cases: gravitational acceleration on surface of Earth, above the surface of Earth, and below the surface of Earth. So as on first case it is on surface of Earth, here it is at depth, so you have to write it is mgd. Now what is equation of mgd, if you remember? Okay, it is equal to, is equal to, it is mgd means it is ge in bracket 1 minus d upon r. Okay, yes, it is equation of gravitational acceleration at depth d, from the surface of Earth. So yes, how to write this? Is equal to, it is mge. Now see, we know that 1 minus d, you are given body weight halfway down the center of Earth. Halfway down the center of Earth means depth d is equal to half of radius, means it is re by 2 divided by re. So re cut, this 2 will be in denominator, so you can write it is mge, and here it is 1 by 2. But see, we know that mge is equal to 250, so it is equal to, it is 250 into 1 by 2. So obviously it is 125 Newton. W2 it is 125 Newton. Clear? So if you know equations, you can easily solve such questions. Yes, you can easily solve such questions. Clear about this? Okay? Yes, it is one easy question. Yes, it is one easy question. Now, chalo next question. What is next question? See, next question is, data is on board, a rocket is fired vertically from the Earth's surface with speed 5 km per second. How far from the Earth does the rocket go before returning to the Earth? Mass of Earth 6 into 10 to 24 kg, radius of Earth 6.4 into 10 to 6 meter is given. Now understand question. See, here it is. It is Earth. It is Earth. Its center Okay, it is its surface. It is its surface. A rocket is fired vertically from the Earth's surface with speed. From surface, a rocket is fired. From surface, a rocket is fired vertically. Okay, with speed 5 km per second. How far from the Earth does the rocket go before returning to the Earth? See here, the initial speed of rocket is 5 km per second. It is less than 11.2 km per second, that is escape speed. So obviously this rocket cannot escape the gravitational field of Earth. It will go up to some height and then it will return on the surface of Earth. Clear? Again, as initial speed of this rocket is 5 km per second, which is less than 11.2 km per second, that is escape speed. It will not escape the gravitational field of Earth. Yes, it will go at some height and then it will return on the surface of Earth. Clear about this? Yes or no? Like this. If it is fired from this point, it will move and up to some height it will go and then it will return back and then it will return back. Do you understand? Hello? Okay. Okay. So yes, what you have to find, you have to find what is distance. What is distance from center up to which the rocket can move? Means you have to find r. Okay, yes. Initially it was here on surface, so it is nothing but its radius, that is r. Its radius, that is r. So yes, I can say it is initial point, and I can say it is final point, that maximum height. Okay, it will move up to this side and then it will return back on surface of Earth. Clear about this? Okay, so yes, a rocket is fired vertically. So now I have to write the data. Initially it is on surface of Earth. Initially it is on surface of Earth. So therefore, total initial energy E1 is equal to, it is K1 plus U1. Yes, total energy means it is kinetic energy plus potential energy. So is equal to, what is K1? Initial kinetic energy. I am assuming the mass of rocket is m. Mass of rocket is m. Let mass of rocket is m. Let mass of rocket is m. Okay, that mass of rocket is m. That is initial square, that is half m v1 square. And what is v1? That v1 is nothing but here its speed on surface its speed. v1 is equal to, it is 5 km per second. Okay, u1 means potential energy. Potential energy of rocket. We know equation of potential energy, minus gm1 m2 upon r. Minus gm1 m2 upon r. So just here it is minus g. First object is Earth, means mass of Earth. Second object is rocket, its mass is m, and divided by, as initially rocket is on surface of Earth, distance you have to write, that is I. It is I. See, initially it is on surface of Earth. Okay, so yes, it is total energy. That is total initial energy E1 is equal to K1 plus U1, kinetic energy plus potential energy. Half m v1 square minus g m upon I. Now we are assuming, okay, let it is moving up to distance r, and then it returns, and that A returns. Okay, means it is final position. You have to find this distance. That's why I am taking it as a final position. Okay. So yes, let it is moving up to distance r. Let it is moving up to distance r. Then at this distance r, what is its total energy? Okay. At distance r, its total energy. Its total energy E2 is equal to, it is K2 plus U. That is kinetic energy plus potential energy. Now you know that at maximum height, okay, yes, if you throw any object, it will attain some height, and at that maximum height, its kinetic energy will become 0, because at that point it will become momentarily steady. Okay, so yes, as a rocket is returning from this point, here its speed V2 will be 0. Here its speed V2 will be 0. Why? Do you understand that? Okay, so yes, at distance r, its total energy is equal to K2 plus U2. K2 will be 0. U2 again minus G, Earth, rocket, and what is distance from center? It is r. What is distance from center? It is r. Clear about this? Hello? Clear about this? Okay, so yes, it is E2. E2 is equal to, it is K2 plus U2. Understand? Okay, you have to think two situations. Initially it is on surface, then it is at distance r. So find total energy on surface, then find total energy on height. Okay, now according to law of conservation of energy, according to law of conservation of energy, E1 is equal to A2. That is, total initial energy is equal to total final energy. What is total initial energy? It is half m V1 square minus G MEN upon I is equal to, here it is 0, minus G MEN upon I. Okay, so see, as mass of rocket, we have assumed it is not given. This M conserves. Any doubt? Hello? Any doubt? Okay. So now, how to find this? Yes, it is V1 square by 2 minus G ME upon I is equal to minus G ME upon R is equal to, it is minus G ME upon R. V1, 5 km per second. Yes, you have to convert this 5 km per second in meter per second. So is equal to, it is 5 into 10 raised to 3 meter per second. 2, that is 2. G, yes, you know value of G. What is G? G is equal to 6.67 into 10 raised to minus 11. ME, mass of earth, given. RE, radius of earth, given. GME again given. What you have to find? Yes, you have to find what is okay, how far from earth does the rocket go before returning to earth? Yes, from R you can also find what is H, because R is equal to, it is RE plus H. So H is equal to, it is R minus I. So yes, once from this equation you find R, you can easily find what is height. Clear? So in such question, yes, you have to think about two situations. Where is initial and where is final? We know that if we throw this drop like this, it is initial point. It will move up to some height, that is final point. Okay, so yes, it is the concept that you have to use. You remember equation of potential energy and kinetic energy. Clear about this? Yes, you have to calculate what is distance r, and that answer you have to write in comment box compulsory. Clear about this? So yes, these two questions from chapter 8 that is gravitation, and I think this is it for today. Good morning, students. Chapter 8, Gravitation. Yes, we will see some more questions. Here it is. The escape speed on the surface of Earth is 11.2 km per second. What is 11.2 km per second? You know, okay. In previous lecture, in previous question, we have discussed that one object is projected with 5 km per second. 5 km per second is actually less than escape speed. So object cannot escape the gravitational field of Earth. It will be within the gravitational field of Earth. Okay. The escape speed on the surface of Earth is 11.2 km per second. So first of all, I will write this data. Okay. Escape speed on surface of Earth, VE is equal to, yes, we know its equation actually, okay. VE is equal to, it is under root 2g n upon I, or you can write it is under root 2g I. Yes or no? Yes, we know this equation, okay. Escape speed on surface of Earth, VE is equal to under root 2g n upon I is equal to 2g I, and its value is 11.2 km per second. Okay. Now here what is question? A body is projected out with thrice this speed. Hello, listen. Hello. A body is projected out with thrice this speed. 11.2 km per second itself is enough to remove object from field of Earth. Object body is projected out with thrice this speed. So obviously object is removed from gravitational field of Earth. Yes, it will move at infinite distance. It will move to infinite distance. It will move to infinite distance. Okay, so yes, what is your question? What is the speed of body far away from the Earth? Far away from Earth means at infinite distance, what is its speed? Okay, so what is difference between previous question and this question? In previous question, okay, initial speed of rocket was 5 km per second, which is less than escape speed. So rocket cannot escape the field of Earth. Yes or no? So it will move up to some height and then it returns on surface of Earth. But here, as initial speed is thrice escape speed, obviously it will move out of field. Okay, so here I will write one statement. Okay, here as initial speed of body is greater than escape speed, body will move to infinity. Infinity, that is out of field of Earth. Out of field of far away means infinity, okay, out of field of Earth. Clear about this? If initial speed is greater than escape speed, object is removed from gravitational field of Earth and it will move to far away means at infinite distance. Yes? Okay, so how to solve this? So yes, we will solve this question again according to law of conservation of energy. Okay, now according to law of conservation of energy. According to law of conservation of energy. What is law of conservation of energy? That is, initial energy is equal to final energy. Yes, initial energy is equal to it is final energy. Then how to write statement? Here, initially object is on surface. Initially object is on surface and then it moves to infinity. Then how to write statement? Okay, energy of body on surface is equal to energy of body at infinite distance. Infinite distance means far away. Infinite distance means far away. Okay, so first of all you have to understand this relation. Okay, according to law of conservation of energy, which statement you have to write? Energy of body on surface is equal to energy of body at infinite distance on surface of earth. Okay, now we know that total energy is equal to kinetic energy plus potential energy. Yes, total energy is equal to kinetic energy plus potential energy. So K1 plus Q1 is equal to K2 plus Q2. K1, we are assuming mass of body is m. So K1, it is half m V1 square. U1, potential energy. Now remember equation of potential energy. Okay, it is minus G it is minus G m1 m2 upon R. Earth and body. So if you can write this minus G m upon RE. Why RE? Because initially it is on surface of Earth. Yes. Is equal to, what is the speed of body far away from Earth? I am assuming V2, half m V2 square. Yes, we have to find speed. U2, what is U2? Yes, it is minus G m upon distance, infinite distance. Yes, infinite distance. Clear about this? Any doubt? Sure? Okay, you understand this equation. Half m V1 square. V1, that is speed on surface of Earth. Potential energy on surface of Earth. Kinetic energy at infinite distance. Potential energy at infinite distance. So now, here it is. Half m. V1, see, a body is projected out with thrice this speed. Escape speed. So V1 is equal to nothing but it is 3VE whole square. Clear? Object is thrown, body is thrown out with thrice escape speed. Okay, minus G m upon I is equal to half m V2 square minus 0. Because at infinite distance potential energy is 0. And 1 upon infinite it will become 0. Okay, another thing, this m cut. So 3VE square means therefore it is 9VE square by 2 minus G ME upon RE is equal to V2 square by 2. Now see, you know each and every value. 9, that is 9, 2, that is 2. VE, here it is 11.2 kilometer per second. Yes, kilometer means 10 to 3. G, 6.67 into 10 to minus 11. ME, mass of Earth. Yes, it is given, but you know what is mass of Earth. See, it is 6 into 10 to 24 kg. It is 6 into 10 to 24 kg. So yes, you know each and every value. RE also, you know, then you can easily find value. But to make this calculation easy, see, to make this calculation easy, see here, VE is equal to under root 2GME upon VE is equal to under root 2 G and E upon I. Square on both sides. So VE square is equal to 2G ME upon I. Now take this 2 this side. So it is VE square by 2 is equal to G ME upon I. Clear about this? To see how to write down. And therefore 9 VE square by 2 as it is minus G ME upon RE. G ME upon RE is replaced by VE square by 2 is equal to V2 square by 2. So 2 cut, and therefore 9 VE square minus VE square is equal to V2 square. So therefore 9 VE square minus VE square means it is 8 VE square is equal to V2 square. Okay, and if you take square root on both sides, then V2 is equal to, it is 2 root 2 V. Yes, it is 2 root 2 V. 8 means 4 into 2. 4 square root 2 and 2 as well, so it is 2 root 2 VE. 2 that is 2 root 2, 1.41 VE, that is 11.2 km per second. Put value, you can easily calculate this question. Okay, so see, it is one important question. Okay, it's one important question. How to solve this question, that is important. Okay, clear about this? Clear about this? Okay, chalo. Now next question. In the corner, last question. Okay, how much energy must be expended to rocket the satellite out of a field of Earth, orbiting Earth at a height of 400 km above the surface? Actually, there is one satellite which is orbiting in orbit having radius, not radius actually, okay, at height 400 km. Mass of satellite 200, mass of Earth and radius of Earth. Okay. So yes, height h. Another chart I have to use. H, height from surface, it is 400 km. Okay. So what is distance from center? So therefore, distance from center. So distance from center, R is equal to, it is R plus H. So it is 6400 plus 400 is equal to 6800 kilometer. Or you can write it is 6.8 into 10 raised to 6 meter. Okay, it is distance from center. Now, what is question? Your question is, what is energy? How much energy is expended to bring or to remove satellite from field of Earth? We know actually concept. Okay, first of all you have to find kinetic energy, then you have to find potential energy, then you have to find total energy. Total energy will be negative, then you have to give the same positive energy to remove object from field. But we actually know what is total energy of satellite. Yes, total energy of satellite, here it is. Okay, total energy of satellite. Total energy of satellite, E is equal to minus GMEM upon 2R. Yes, you know this value. And therefore, energy given to remove it from field is E dash is equal to, it is plus GMEM upon G 6.67 into 10 raised to minus 11, ME 6 into 10 raised to 24, M 202, that is 2, R it is 6.8 into 10 raised to 6 meter. So yes, you can easily calculate this. Yes, you can easily calculate this. Okay. So yes, again some important questions from chapter number 8. Okay. Yes, for today this is it.